Okay, so let me first share my screen. Okay. Okay, yes. So, um, hello and good day to all who will be watching this video. And I am Melard Ilocero, student of LPU Laguna, and this presentation is originally a group project, and what I am presenting to you is my part in this group project. So the title of this presentation is about wave propagation. So my group mates is Amaya Elise A. Arbis, and Gregorio Masakupan. So this presentation topic and ideas were based from the book given to us by our professor in electromagnetics. This is a book about Navy electricity and electronics training series. So what our group task is to present and demonstrate our understanding about the first chapter of this book. So as you can see here, so the chapter 1 is about wave propagation. So this is just a continuation. So apparently the original plan for this is we will be reporting this live, so that the presentation is um, already attached. So but due to some circumstances, we will be just reporting our own part individually. So basically I will be going to my part. So our team and I divided this wave propagation topic into three groups. So first one is the introduction to wave propagation. So this is reported by Mr. Gregorio Masakupan. Then I will be the one reporting this part. Sorry. So 17. I'll be the one reporting the sound waves, and lastly about the uh, light light waves, it will be reported by Miss Amaya. So pardon me, I will be transferring back and forth this presentation screen so that you can identify my part. So and also I would like to clarify that I am not an expert to this. So hopefully, what I am saying is my own understanding, and hopefully, uh, you have learned a lot from me. So let's start. Okay, so our topic is about wave propagation, and what I am saying earlier. So is the first part will be reported by Greg Pascupan. Then I will be doing this explanation about sound waves. So to be able to grasp important information about these sound waves, so to be able to make you understand this more, I am um, preparing and opening this book so that you can identify what part am I, or nasang part na ako nung dinidiscuss ko po. Yun lang po. Okay, so bali magbabalik-balik yung ano ko, yung screen ko kasi medyo maraming ideas na ano. So this book is have so much ideas to learn. So I am encouraging you to understand and read this book because there is so much knowledge to be learned from this book. Okay, so let's start. So my part is about sound waves. So what is written, and what is written here is a wave of compression and rarefaction by which sound is propagated in an air elastic medium such as air. So this is done through a propagating medium, and this propagating medium is any material substance that can be used for the propagation of signals, usually signals in the form of modulated radio or signals like or acoustic waves from one point to another. So what are different terminologies that will be applied in sound waves? So these are some of the important terms to be used, but there is so much more terms to be remembered with this topic. So first one is we have the cycle. So we all know and familiar for this to this sets of terms because we are already discussed this in our physics and physics 2 courses. So first one is the cycle. So cycle is a combination of one complete positive and one complete negative alternation of a wave. So it has one crest and a one through. So another one is the wavelength and amplitude. So wavelength is the distance in space occupied by one cycle at any given instant. So this is a wavelength. Then another one is the amplitude. So this is the height of the wave crest above the reference line. So it indicates also the amount of energy that the wave transmits. So you can see here. Then another one is the frequency. Frequency in the text means that the number of sound waves or vibrations of cycles of a wave train in a unit of time. So we have this, look, this is in a time frame. So if there are lesser cycles, this have low frequency, then medium frequency and high frequency. Then another one is the velocity. So velocity by definition is the rate of change of position or displacement of an object with respect to time. So we are understanding this sound waves because studying these principles of sound waves motion will help us to understand the action of sound waves and a turning point to understand more complex radio and radar electromagnetic waves, which we all knew that we will be discussing on our upper years po. So this is how or this is the value of understanding this sound waves or any wave propagation. Okay, so first of all, let us define what is sound. So sound is the sensation of hearing, and it refers to a stimulus that is capable of producing the sensation of hearing. It limits sound to what is actually heard by the human ear. So this is a generalized definition of this sound, and I want to emphasize more detailed and more complex explanation for this. So we will be opening this PDF file. So the wave propagation transmission lines and antennas. So it is said here that the word sound is used in everyday speech. So to signify a variety of things. So one definition of sound is the sensation of hearing. Another definition refers to the stimulus that's capable of producing the sensation of hearing. And the third definition limits sound to what is actually heard by the human ear. So we have here, what I'm telling here is, so this long paragraph here. I'm sorry. Okay, so I'll get some important terminologies here. So this to distinguish frequencies in the audible range from outside the range. So we have here the sounds capable of being heard by the human ear are called sonics. Then the average person can hear sounds above 10,000 hertz. It is a standard practice to refer to sounds above that frequency as ultrasonic. So sounds between 15 hertz and 10,000 hertz are called sonics. Then, lastly, below 15 hertz are known as infrasonic or formally referred to as a subsonic sound. So, yung mga hindi pala normal nating naririnig na mga sound, meron pala yung mga frequencies via hertz na kumbaga dinidefine siya, kumbaga kinaklasify siya. Ayun nga yun, yung sonics, ultrasonic, and then yung infrasonic. So, yun lang po yung gusto ko siyang i-emphasize deeper classification. So, we can say that classifications of the sounds we hear. Okay, so let us go with this requirement for sound. So we have here a source, medium, and a receiver. So let us identify first what are the meaning of these three. So So source is any object that moves rapidly back and forth or vibrates and thus disturbs the medium around it and may be considered as source for sound. So bells, we all knew of that. Bells, speakers, and string instruments are familiar sound sources. Also our speech, di ba? Mayroong nagbabibrate sa atin dito kaya tayo nakakapag-produce ng sound. Kung pipigilan mo yung vibration, hindi ka maririnig. So, anything na nagmo-moves na back and forth and nagbabibrate, syempre nakakapag-produce na ng sound. So, the other one is the medium. So, medium is the material through which sound was traveled. So, the density of the medium determines the ease, distance, and speed of sound transmission. So the higher the density, so I would like to emphasize this, the higher the density of the medium, the slower the sound travel through it. So another one is the detector. The detector or the receiver. So the detector acts as the receiver of the sound wave because it does not surround the source of the sound wave. Detector absorbs only part of the energy from the wave and sometimes requires an amplifier to boost that weak signal. So to be able to explain this further, uh, the text offers this medium, offers this figure, or okay, the offers this figure. So we have here, you can see the figure here. So this is what happens here is there's an electric bell surrounded by a rubber band here. So there it is an electric bell. So it is surround sorry this is suspended by a rubber band. So hindi siya kumbaga may nakakapit na rubber band sa kanya para mapigilan niya yung ano. Okay, so it is enclosed in a container and naka-attach siya sa isang flat surface na may vacuum pump, or we can say this vacuum pump either naka-attach siya sa vacuum pump or vacuum generator or vacuum line. So yung mga vacuum, meron kasi mga vacuum line sa sa experiences ko sa mga manufacturing industry or any laboratory that nagpo-produce ng vacuum. So meron yan silang mga vacuum generators. Okay, so example, meron siyang ganon. Then meron siyang knob dito. And yun nga. So meron tayong dalawang contacts here. And these contacts are attached to a supply. So we have here 1.5 volts, two batteries na meron siyang 1.5 volts, and we have here a push button switch. So basically this is momentary, normally open, momentary push button switch yan. Then yun nga, naka-attach yung isang side disk to this contact. So ang mangyayari is if we push this button, so basically dapat magkakaroon na sila ng contact, mako-complete yung circuit, and then magrarang na tong bell. So what we have here is we can identify here that the source of our sound will be the speaker. Then what do you think is our medium here? So our medium here is the air inside this closed container, or air inside air in the surrounding of the bell. Then the receiver here is us. So the one we will be hearing the noise. So apparently, as we push the button, so the circuit is complete. Then the bell will ring. So we can hear that. So that we can say that we can hear the sound. So what do you think will happen if we open the knob here and the air in here vacuums out? So, meaning there will be no sound inside this medium. So, what will happen if there is no sound? There will be no medium. So, hindi natin marinig yung sound. So, ganun lang ang ibig niyang sabihin. So, for example, to be more generalized to help you understand this more clearly. Example, kumulog. So, kapag kumulog, maririnig mo yung sound. Ibig sabihin, ah, kumpleto yung ano, yung kumbaga yung sorry. Kumpleto yung requirements for us to hear the sound. So we have the source, which is the lightning. The medium is the air. So that the sound travels to the air, and we are receiving it. So for example, may tatanggalin tayong isang part dyan. For example, tinanggal natin si medium. Ang mangyayari, sorry, tatanggalin natin yung receiver na lang para mas madali niya ma-identify. Example, kumidlat. So ano, alam naman natin na kapag kumidlat, magkakaroon ng kulog. So, we can have a source or a sound. So, syempre magta-travel yung sound through the air so that maririnig natin. Kung halimbawa, walang receiver, ibig sabihin wala ka dun sa scenario na 'yon, o kaya nakita mo lang siya sa malayo. Yun, yung nakita mo lang siya sa malayo, wala yun, hindi mo narinig yung medium. Sorry. Wala yung medium kasi hindi nag-travels yung sound papunta sa'yo. Kumbaga, yun yung scenario niya. Kung wala yung isa dito, hindi magiging complete tong pagkakaroon ng sound. So, kumulog nga, tapos, siyempre, may air sa paligid niya. Kumbaga, meron kang medium. Wala ka naman doon. Kumbaga, sobrang layo mo naman doon. Walang receiver. Kumbaga, wala kang narinig. Walang sound. So, that's the main logic of this requirements for sound. Okay? So, next is we will be going to the characteristic of sound. So, we have here three items. So, this is pitch, intensity, and quality. So let us identify what is pitch. So it depends on the frequency of wave. So we have here pitch. So pitch is used to describe the frequency of the sound. So as we all know, to be able to explain an example, so to be able to give an example of this pitch, we know we as a person tries to whistle. So, alam naman natin yung characteristic ng whistle, di ba? Meron siyang ball sa loob. So, pag ihip natin, so magbabibrate siya ng yung ball, tatouch siya sa metal or any component nung whistle, either plastic or metal. So, sa pagbangga ng yun, nagkakaroon siya ng sound. So, greater the impact or the dami ng impact na nagagawa nung ball dun sa paligid nung whistle, the greater yung pitch na napoproduce niya. So to be able to understand, when the frequency is low, an object that vibrates many times per second produces a sound with a high pitch. As with a police whistle, the slow vibrations of that heavier. So, for example, strings of a violin cause a low pitch sound. So, dahil nga mas mababa yung niya, mas mahina yung frequency niya. Kumbaga, frequency of the wave determines din yung yung pitch. So, when the frequency is low, sound waves are long, and when it is high, the waves are short. So, thus corresponds to the meaning of the pitch is used to describe yung frequency also ng sound. Okay. So, it's getting dark. What happened? So, it's getting dark. Because of the typhoon that we have. Okay. So, let us continue. So, another one is the intensity. So, it depends on the amplitude of waves. So, we have here the intensity of sound of the given distance depends on the amplitude of the wave. So we all knew that sound is omnidirectional, so it is heard in all directions. So the distance between the waves and the sound sources increases. So As you move away from the source of the sound, the lesser the sound you will hear. So we all by that explanation we can we can we can identify, or we can conclude that that the yung ano daw, yung intensity ng sound nakadepends lang yan sa layo mo dun sa ano, sa layo mo dun sa source ng ano, source ng sound. Okay? So thus is megaphone and directional loudspeaker are example of that. So they are focusing sound in the desired direction kasi nga yung main characteristic ng sound is to para marinig ng lahat. So ang purpose nung para may pataas mo yung intensity ng sound, ipo-focus mo siya sa isang direction lamang. So that's the meaning of that. Okay? So we have here sometimes nagkakalituhan tayo or nagiging confused tayo about intensity and loudness. So intensity naman is yung measure of sound energy of a wave. So loudness naman yung sensation na nararamdaman ng ating mga pandinig doon sa ano, sa lakas, kumbaga nakadepende lang siya, yung loudness nakadepende siya sa tao. And then yung intensity naman, yun yung about dun sa wave. Okay? So, siyempre, meron tao na mas malakas yung, kumbaga, mas sensitive yung hearing nila. Kaya nagdi-differs yung loudness as per person. Okay? So, another one is the quality. So, depends on the forms of the wave. So, to be able to expound this, so when you strum a guitar with a chord, it produces a pure tone of specific frequency. This pure tone is produced by regular vibration of the strings of the guitar. So the quality of a sound depends on the complexity of a sound wave. So therefore, this concludes that by the sound quality, we can identify and recognize sounds including the voices of different persons. So minsan na ano yan, 'di ba? Sa quality pa lang ng sound, kumbaga yung internal waves niya, or yung by hearing pa lang we can identify na yung tao. Kahit nakapikit tayo, marinig natin yung boss ng mga natin, mahal natin sa buhay. Kilala na agad natin sila. So I would share an experience. Dati nga kasi kami, nung bata pa lang ako. Hindi naman siguro ganun katagal po 'yun. Whistle pa lang nung tatay ko, kilala ko na siya. Kaya baga, pag nag-whistle na yun, kailangan na namin umuwi ng bahay. Kasi pag hindi kami umuwi ng bahay, yun, sigurado may palo. Okay, so that is an example of the characteristic of a sound. So it has also a quality. Next one in the slide is we have here elasticity and density. So let us define each. So elasticity is the ability of a string body to recover its shape after deformation, and as from a vibration or compression. So density, on the other half, is the mass per unit volume, the medium or substance. So we can so to be able to differentiate more, so sound waves travel through any medium nga to a velocity that's controlled by the medium. So syempre magdi-differs yung velocity ng sound mo kung ano yung medium mong gamit. So that is what important yung yung elasticity and density. So the measure of elasticity of body is the force it exerts to return to its original shape. So yung density ng medium is the raising the temperature. Raising yung temperature ng medium has the effect of increasing the velocity of sound through the medium. So meron silang formula to get yung medium. This is yung B is equal to the square root of E divided by the D, or elasticity over the density. So meron lang tayong dito sa natin, comparison of velocity of sounds in various medium. So marami kasi tayong types ng na medium. So yun sa example nga pinakita earlier, yun sa bell, we have here yung air. So yung 32 degrees Fahrenheit, ito yung niya, reaction ng velocity niya. So, kumbaga yung sound na, yung velocity ng sound na yung speed, yung velocity niya doon sa certain temperature na yan. So, we have here different kinds of medium, air, aluminum, carbon dioxide, fresh water. So, ayun, yun yung mga types niya. So, alam nyo ba guys na yung kung saan malakas yung yung malakas yung speed ng ng sound. So, that is also explained by supposed to be explained by Mr. Gregorio on his presentation uh, before me. So dapat mas mabilis siya sa water. So yun yung reason why yung mas malalakas yung pandinig ng mga isda kaysa sa mga tao kasi mas sila daw bukod sa sila sa mas kaya bukod sa kaya nilang tumira sa tubig, mas malakas yung pandinig nila kasi yun nga yung environment nilang yun sanay sila sa ganun. So yun lang. So another one. Okay, let's go with the presentation again. So this will be apparently my last slide with my part. So what is acoustic? So acoustic is the science of sound. So we have here acoustical effects. So we have echoes, refraction, reverberation, resonance, and noise. So to be able to explain this, actually, ito na talaga yun sa dulong part nung presentation niya. So ito na siya. Acoustics, echo, refraction, reverberation, interference, and resonance. So to be able to explain this, I have gathered some key information to that. So echo is the reflection of the original sound wave as it bounces off a distant surface. So the echo sound produced will not be as loud as the original wave. So for example, we are shouting in high places. So I don't know what happens to that or ano yung medium niya na binabanggaan kung bakit naririnig natin siya. Pero yung naka-enclose tayo sa isang room, di ba parang naririnig natin yung echoes din natin. For example, we goes to the CR, nagtataka tayo bakit ang ganda ang ganda ng boses natin. So, yun yung isa sa main reason nun, yung every voice that we speak, meron siyang echo. Kasi, bumabangga yung original na voices natin dun sa walls. So, yung sound na napoproduce natin, nababounces back siya. Kaya parang kumbaga, ang haba ng binibitawan nating salita. Kumbaga, kung bakit mas gumaganda siya. Hindi ko rin alam kung bakit ganon. So, yun nga. So, as we produce yung sound through our mouth, it bounces off at a distant surface. So, that's the reason why echo is produced. So another one is we have yung refraction. When sound waves traveling at a distance at different velocities pass obliquely at an angle from one medium into another. So the waves are refracted, that is their line of travel is bent. So this is just like somehow connected with the refraction that is supposed to be reported by the first part or the introduction to the wave propagation. So we can say say that sound is refracted or is bent by the medium. So habang nag-iiba yung medium mo, nabe-bend din siya. So parang same lang din siya dito I'm sorry, medyo nagpapalipat-lipat ako Pero ito, parang ganito lang din siya. So, yung supposed to be reported by Mr. Greg Masakupan. So, we have here kung paano siya nabibend. So, we have here two different kinds of medium. So, we have here parade ground and a float field and parade ground. So, this is an analogy. So this is pala yung niya. So parang ganito lang siya. We have here an air, a more dense medium, and another air. So sa air, ganito yung angle ng niya, ng movement or ng movement ng ating sound. Then kapag nagano siya, pumasok siya sa ibang medium, nag-iiba yung ano niya, yung pagkaka-angle niya, or yung you can see here that this is the original movement supposed to be ng ating sound waves. Then ano siya, na-bend siya nung nagkaroon siya ng nung pumasok na siya sa more dense na medium. So apparently babalik siya yung pagkaka-angle niya nung makalabas na siya dun sa medium na yon. So that is what I understand about the refraction. So hopefully there is a chance that we can clarify these ideas if given a chance. So sila sir lang po siguro makakapagpaliwanag nun. So what I am saying is what I am understanding about this sound this acoustical effect. So another one is the reverberation. So reverberation is the multiple reflections of sound waves. So reverberation seems to prolong the time during which the sound is heard. So just like what I am saying earlier, so somehow medyo connected silang dalawa, yung reverberation and echo. So by nature it should be a real quick sound, but due to reverberation, kung bakit siya napoprolong. So by the time the sound has reached the ears of a distant observer, it's usually drawn out into a prolonged roar. So just like what I'm telling an example earlier, so yung about dun sa sound ng kulog or yung dagundong, 'di ba parang medyo sobrang saglit lang niya kasi nung mangyari yung sound, dapat ano lang 'yun, kumbaga isang reaction lang 'yun. So due to reverberation, nagba-bounce yung sound, kaya siya parang tumatagal. So parang same lang din yun sa ganito eh. Pero different scenario siya. So, dapat, pagka nung nagkaroon ka ng reaction, isa lang yung sound. Kaso, dahil nga doon sa reverberation, nagba-bounce yung, nagre-reflect yung natin, sound waves, kaya siya nagkaroon ng kaya siya parang napoprolong. So, that's conclude what happens when we heard what's it called in English? The sound after the lightning po. Thunderstorm. Hindi. Okay? Another one is the interference. Interference. Okay? This is not included with but it was supposed to be here. Interference. Okay, so interference is any disturbance, man-made or natural, that causes an undesirable response or degradation of wave, referring to as interference. So if this, for example, someone is calling, then yung mga naririnig nyo sa halimbawa natawag ka, tapos bilang nagaganon. So yun ibig sabihin nun na-interference siya. So parang yun sa mga pelikula. I don't know what happens there, but that's the scenario of that. So there is a possibility na pwedeng ma-interfere yung natin, yung sound waves. Another one is the resonance, a certain pitch that the frequency of vibration of the voice match the resonant or natural frequency of cavity. So the resonant frequency of a cavity is the frequency at which the cavity body will begin to vibrate and create sound. So when the resonant frequency was reached, the sound of the voice was reinforced by the sound waves created by the cavity, resulting to a louder tone. So lastly, the noise. So the most complex sound waves that can be produced is noise. So it distracts and distorts the sound quality that was intended to be heard. Noise has no tonal quantity. Noise is generally an unwanted disturbance by spurious waves originally from man-made or natural sources such as jet breaking the sound barrier or thunder. So yun lang. So today ano ba yung noise? Basta maingay lang. Kumbaga, di mo siya ma-explain. Kumbaga, ang pleasant sa ear. So, that is noise. So, yun lang yung mga acoustical effects. And, okay. So, this basically end my part in this wave propagation reporting of us. I hope you have learned something from me. And, sana rin hindi kayo naguluhan dun sa papalit-palit ko ng ng screen. and application niyo. So, sana po marami kayong tutulan and ingat po kayo lagi. Maraming salamat.